Hello again, and welcome back to Raspberry Pi for the older generation, our next video. First things first, quick couple of shout outs actually. I'd like to say a big thank you to my first Patreon, a guy named Aaron. Thanks for supporting me, Aaron. And also a big shout out to all our subscribers. We're already up to 62 subscribers. That's great, that's great. I hope you do enjoy the content. I think I am getting better at doing these videos. As a newbie doing this, you know, I think I am doing all right. Anyway, in this video, what we're going to be doing is, you know, in the last video, how we looked at how to control a servo from 0 to 180 degrees. In this one, we're going to use the potentiometer to control the servo. And what we're going to be doing is basically putting two configurations into one, but with extra lines of code for the potentiometer to control the servo. Right, so let's have a quick look again at wiring up the servo. As before, we got the servo connection on the board here, and top wire furthest away from us is the yellow wire, that's the signal wire. Next one along is the 5 volt, because servo needs 5 volts, it's the red wire. And the wire closest to us is the brown wire, which is the ground wire. All right, and we're going to be using this potentiometer just here. And here's our servo, so you can see it. All right, so let's go to our instruction view. Let's open Thony. Still got the Joy configuration open. Template. Okay, so we've got our template. There's a file. Save as. I'm going to call mine knob, because basically we're going to be using the knob, and that's a potentiometer, but it's still a knob. All right. .py, don't forget the extension. All right, the Python extension. Right, you can see me, so let's go to here. Yep, we need to import our GPIO pins as GPIO, because we're going to be using the physical pins. What I might do, I might start a playlist of using the breadboard. I think that might be an idea, because I think more people have got the breadboard than they have the projects board. So we need to import time. And what's next? From ADC device, we need to import star. That means import all. Right? Nope. Why did I do that? Remember that if you want to put a comment, use the hashtag. It doesn't interfere with the configuration. Right, now we need to do our ADC equals ADC device, and it's 0 times 48, brackets off. So brackets on, 0 times 48. If you don't know where to get that number, because we need to define the ADC device class object, you have to look at it in one of my previous videos. All right, how to get the command and how to find out what the number, but mainly on all Raspberry Pis, the ADC device is located on 48. All right, now then, we need our, obviously, all capitals. Yeah, sorry, don't need a space there. Underscore, yeah, equals 0.5. Finds the pulse offset of the servo. Remember this from the other one. Now we need to do our minimum and maximum. So it's servo underscore min underscore duty. Yeah, all capitals. And it's equals 2.5 plus, and want the off-C duty, yeah? Defines the pulse duty cycle for the minimum angle of the servo. Remember we did this before in our last project. Underscore duty. Right. Now we need our max. Servo underscore max. Where's my X? Underscore duty. And that's equal to, I think it's 12.5. Yeah. 12.5 plus the off C underscore duty. Okay. And the next thing we need to do is name our pin and put it on our GPIO. So it's we'll call it servo pin. Make sure I spelled that right. Servo pin, yeah, because it's important. Remember, you can name it what you like, but as long as you, when we reference that attribute, you put the right name. And we're going to name it, and it's on number 12. Right. Now remember we had this extra map brackets on, and it had the value from low, but it's exactly the same as this. So it's value, comma, from, capital L, low, comma, space, from, high, yeah, comma, to, low, capital L, comma, space, to high, capital H, yeah, brackets off, space, /. Then it was from high, dash, from low, yeah, from, let me just make sure I got this right, high, dash, from, low, capital L, brackets off, plus, to, low, capital L. All right. Let me just check that. Brackets, why is that? So I forgot to turn a bracket off. Let me just check. Duty value, high. Too low. Hang on. Def map value, comma, from low, comma, from high, comma, too low, comma, too high. Let me just take this out. I think I might have started putting that twice. Let's have a look. Value, too high, colons. Right. So that maps the value from one range to another. Right. So yeah, I started copying it twice. Value from low, from high, too low, too high. Right, okay, return. Brackets on. Too high, dash, too low, capital L, brackets off, star, brackets on, value, dash, from low. Right. Then it's brackets off. Right. Then we come forward slash, brackets on, from high, capital H on the high, dash, from low, capital L on the low, brackets, plus low. Right. Didn't press the shift. Right. Now we go into our setup. That looks fine to me. Right, let's come down to our setup, and it's global. It's global ADC. Right. Just get where I am. Right. Global ADC. If, don't forget the colon, sorry, auto indent. If, brackets on, ADC.connect, sorry, ADC.detect, I to C, capital I to capital C, brackets on, 0 times 48. Right. Sorry. Let me put my colons in there, sorry. And then it's return. And it's ADC equals ADS 7830. Because remember, we have to use that converter for analog to digital from the potentiometer. Yeah. Brackets on, 0 times 48. Brackets off. And what did I forget to do there? Yep. Spotted the mistake. That's what's good about this Thony. Shows you where your mistakes are. Right. Now for the minute, I'm going to cut this out because it comes in later on down the code. We need our else, the print. Right. So let's space out a couple of times. And backspace, we want to be coming under the else. Yeah, so this is all in line under the else. We're now going to put our global P in. Yeah. And now this is where we put in our board, our physical board numbering. So that's Control V. Right. Then we need our GPIO dot setup. Yeah. Brackets. Servo pin. Yeah. Comma. And it's a GPIO dot out. Good. All capitals. Brackets off. Let me bring this up a bit so you can all see it. Then we need our GPIO dot set mode, output. And it's servo pin. GPIO dot low, brackets off. Yeah, done that all before. Make servo pin output at low level. Right. So that's that. Now we have to do the frequency for the pulse width modulation, P. Yeah. equals GPIO dot PWM, all capitals, servo pin, comma 50, brackets off, and it puts our pin at 50 hertz, right, 50 hertz, and then we have to do the P dot start. Brackets 0, brackets off. Right. Now, come up a bit. Now we have to do the servo bit. Backspace all the way to the left. And it's a def, remember this? Servo right. Capital on the W. Oh. Yeah, servo right, brackets on, angle, brackets off. Yeah, make the servo rotate to a specific angle, 0 to 180. Colons. Right, and then it's if, brackets off, brackets on, angle is less than 0, brackets off. Now we're going to tell it what to do, colons, angle equals 0. Right. Return, and make sure I got this right. Backspace under the if, else if, ELIF, yeah, brackets on, angle is greater than 180, brackets off, colons. So that's our movement, 0 to 180. Yeah, angle equals 180. All right. So return, backspace, come under the elif, P. I think it's dot. Yep. We're now going to do our change duty cycle. Capital C, capital D, capital C, cycle, I just spelled cycle, C-Y-C-L-E, yeah, brackets on, our map, brackets on, angle, comma 0, comma 180, comma servo underscore min underscore a duty, yeah, comma servo underscore max underscore duty, brackets off to close the first bracket. Right, map the angle of the duty cycle and output it, yeah? Right, let's come to our while loop. Go here, come down a bit. Okay, value, right, equals ADC dot analog read, capital R on the read, brackets on to brackets off, read the ADC value of channel 2. All right, return under the V, Servo right. Brackets on. Round. Round. Brackets on. Value. /255. Our maximum bits. .0. Times. Star. 180. .0. And then 2 brackets. Close the first, brackets off. Close the first, close the second. Right. Under the servo right, print. Good old print command. Brackets on. Quotes. Sorry. You can use quote or double quotes, but as long as you have the same at both ends. I think I've told you that before. ADC space a value space colons. Remember our %D. %D. Quotes off. Yeah. Oh, why have I got a 5%? Yeah. Okay. Colons off. And remember, brackets on, value, brackets off, close the first bracket, bracket off, close the second bracket. Right. Then we want a time.sleep. And that's going to be 0.1. Brackets off. Right. So let's move this up a little bit. That's our while loop, def loop. Yeah, a def loop, yeah. What we need to do, we need to put a little line in here first. Right, and it's p.stop, yeah? No argument. Brackets off, brackets on, brackets off. GPIO.cleanup. Let's do a quick save on that. Right, now, let's make sure my board's on. Quickly go through. Right, only way we can do it is turn it on. Okay, line 8. Servo min 2.2 plus offset duty. Then we come up. Let's check. Servo min do offset. Name offset is not defined. Right. ADC equals ADC device import. ADC device 48 48 off C and right. Didn't put the duty in there. Okay, Control C. Let's hopefully. That's the only problem. Should we start again? Line 9. Python doesn't know what offset duty stands for. Right. Line 9. Again. Stop it. Typo. Put 2 E's in. Right, let's save it. We're all human. And let's start again. Oh dear. Line 13. Line 13. High, low. Value high. Capital L. It's all spelling mistakes, most of it anyway. Let's just do this. Oh, come on, this time. 9:13. Right, let me just check this. Too low. Try it again. 9:59. 9:46. Print. Let me just stop this. 46. Let's check it. $9.46. The ADC value. Colons, percentage, percent. Sorry. Percent. Nope. Percent. Got to put that in, then it's brackets on value. Right, I've got something happening. Got something happening. Right, let's try it again. Ah, here we go. Well, a few little mistakes there, Let's come over. Right, as you saw, as I'm moving the control, you can see it's going down to 0. Bring it up, and it's going 254. So let's put it in the middle. Let's go over so you can see it on the overhead. All right. See it. Let me move it so you can see it together. So I'm moving it to the left, goes to the left. Moving it to the right, goes to the right. So there we are. We're using a potentiometer to control a servo. Wow. Few little mistakes there, Let's turn this off, making funny noises. But anyway, we got there. That's how you control a servo with a potentiometer. Well, guys, thanks a lot. Hope you enjoyed the video. Don't forget, thumbs up. And please subscribe. And any comments, put them below. And then again, and thanks again for your support with all of the subscriptions and my first Patreon. Bye bye.